So we have this idea. We know we have this array over here. It's log of n. And I guess that implies that we gotta like on each iteration we gotta split the array into half. Like we don't want to be checking more than half of the array at each iteration. So be able to take off like half of the values here, then half over here, right? And then until we get like to one single or two, until we're basically left with no elements, but reducing it by half at each step. So that still implies some kind of way of determining which half you want to go into. But I think what's more important is kind of looking at these two kind of lists, because we know by we know by the look of this graph that this element, this kind of sublist is ascending order, and this one is ascending order. Like, of course, we know that this entire thing from 0, 1, 2, 4, 5, right, this is all ascending. But we know this, strictly speaking, like, after the 7, it's not ascending, right? It's going down to 0. But we know until that point, it's going to be in ascending order. Like, it's going to be 4, 5, 6, 7. All of these are ascending, right? The graph kind of demonstrates that. And here as well, 0, 1, 2, it's all ascending. So we have like a left sorted and a right sorted kind of case. Okay, so let's kind of write that down. And let me write that down somewhere here. So we have a left sorted, and a. Let me actually. Oh, I am timing myself. Nice. Okay. And a right sorted. Okay, so we have these like two different scenarios. Can we determine one over the other? Like, how do we know when we're Can we determine successfully when we're in the right sorted? That I don't know. The reason why I don't know is because like it's not necessarily that this right sorted could begin here, right? Conveniently in the right half of this list. It could kind of begin like could have just been 7, 0, 1, 2, from the very beginning. And so it could have just been in the second, like the left half. But 7, 0, I guess it's still right sorted. Okay, so I'm cheating a little bit here because this is what LeetCode mentioned. They said to check the first element here, right? And check if the target is greater than this value. If it's greater than this value, then it has to kind of be within this range over here. If it's not greater than this value, then it has to be in this range. But again, this is pretty specific to this example. I'm thinking of an example where we have 7, 4, right? And now the two sections are like this. We have our left section right here, and then we have a right section right here, right? And then if this is greater than our target, let's say the target is 0, well, it's in the left sorted, so it's in this one. Sorry, just 1 second. So we have our target 0. Okay, is 7 greater than 0? Or maybe it should be the other way around. Maybe it should be like 7 less than 0. Wait, hold on. This element, okay, so this element here this is false, and so it goes in the right. Like, makes sense. Like, right? 7 is less than 0. That's false. So it, it can't be in this left sorted one. It has to be in this right sorted. How do we know where this right sorted begins and ends? How does this help us determine that? Does it help us determine that? I'm so lost. I think according to NeetCode it did. So what does this mean? This means num 0 is greater than target. Oh, sorry. It should be like this. Well, I guess anyway, really doesn't matter. But what I'm kind of determining is that here on the true path we know that it's in left sorted for some reason. I don't know that reason yet. I'm trying to figure that out with you right now. And then if it's not true, it's in the right sorted. And I guess in both scenarios that makes sense. But okay, now it's in the left sorted. Now is it correct for us to look at this in terms of if I had just take the left sorted, again, I'm very heavily relying on the NeetCode video right now because I would not know that I need 2 more cases like this by myself. Okay. Left half, right? And right halved. You see what I mean? Once I go into the sorted kind of argument, do I go into this, right? Or do I go in this? How do I determine that? Or is that even the right approach? Am I understanding this correctly? Because I think this still relies on the midpoint kind of technique, right? Where you find the middle here, and so forth. What's the condition? guess we can use like our knowledge from before, right? And when I say knowledge from before, I mean like the binary search question that we did over here, was it, right? How do we know if we want to go to the left or right? Well, we just did like a nums mid, right? So I feel, is there a better way I can write this for myself? I don't know why this always confuses me. Okay, so the value in the middle, is that less than the target? And then does that go in the left or right? If 7, right? Is less than the target. Then that means you should go into the right search, just right one, because it's like 8, 9, 10, all that. But that doesn't make sense. And if it's the other way around, it should go in the right half. Well, that's not going to lead you to the right answer. Yeah, that's definitely not leading you to the right answer. Maybe that's what the left sorted and right sorted part is for. Can you go in both the left half and the right half? I don't know, man. I'm so lost. I'm gonna watch the NeetCode video again. I think I spent 44 minutes solid time. Right? But you know, I think you know, these cases are really just not making sense to me. So I'm gonna review the NeetCode question, the NeetCode video, and see what I'm missing. Though this type of problem solving I need to work on. So I'll kind of make a note of that in my tracker. Yeah, I'll do that.